Hi guys, in today's edition of the tutorial, we'll be looking at how to convert USD to its equivalent value of Ether, and why is it necessary for us to know how to convert USD to its equivalent value in Ether. Let's say you are working as an independent contractor or you are working with an organization. So there might come a time maybe where you're asked to, implement something like a thrift application, abi, or something like a crowdfunding application. In this kind of application, you might want to set the minimum amount allowed to be contributed to this specific application. Let's say we set the minimum amount to 50 USD. Then for each funds that will be contributed to this application, then we need to look for a way of writing a check to confirm that the money that is about to be contributed is up to the minimum amount. So now this is the reason why we need to understand how to convert various currency pair to its equivalent value in cryptocurrency. Let's say for example, but for this tutorial we'll be making use of the Ether USD currency pair. So we'll be converting USD to its equivalent value in Ether. Now we've talked about that. Now let's begin to let's begin write let's begin to write our code. Then let's create our file. The name of our file will be USD converter, USD converter, USD converter.sql, then XPS license identifier, then pragma solidity, then our solidity version 0.8.0, then our semicolon, then create our contract, then USD converter, USD converter, and so now we said there will be a minimum value that will be set in our application. Let's say now in our case, the minimum value that we want to set for this our smart contract will be 50 USD. So minimum minimum amount, minimum. So I actually just got my PC. So I don't know, my keyboard is malfunctioning, so that's why I'm copying the code to symbol the uh, from the from that's why I'm copying the equal to from there. So now let's set the minimum value to be equal to 50. Then now we set our minimum value. So the next thing is for us to write our logic for converting from USD to Ether. Now, for us to convert between two currency between two token pair or between two currency pair, at least we need to look for a way of getting how many units of a specific currency of a specific token is equal to one token. So we need to look for a way of getting this data. So that is where the Chainlink Oracle come in. So Chainlink Oracle are basically a Web3 service that enables us to get off-chain data uh, to it enables us to get off-chain data in our smart contract. So, but the way it works is it enables us it handles it in a decentralized manner. So now we've talked extensively about what Oracle is and all that. So you can go through our YouTube channel to check about what Oracle is, and so you can gain more knowledge and understanding about what Oracle is. So now we've set our minimum amount to 50 USD. Then the Oracle we'll be using for this our smart contract to be the Chainlink Oracle. So now let's go to the Chainlink Oracle. Uh, developer. So now let's click on the data feeds. So now, although Chainlink provides a lot of service, but the service we are going to be making use is data feeds. So now, what is price feed? Now, if you see at the top here, you see price feed contract address. You know, as I said, the in simple term, what Chainlink help us to do is to get data, off-chain data. When I say off-chain data, data that are not available on the blockchain, because there's no way for us to get the the rate of a specific token pair. So these data are not available on the blockchain. So now we need to look for a way of getting this data, and that's why we are making use of this Chainlink Oracle. Now this Oracle have what is called price feeds. So what is price feeds? Price feed are basically smart contracts that is created to handle each token pair. That is, it is this contract we are going to interact with to get the specific rate of a specific token pair. Let's say now we want to get the rate of a let's say we want to get the rate of Ether USD. Then by your right hand side, you click on the Sepolia testnet button, then you scroll down. So this is it. You see Ether USD pair. So this is the contract address that on the Sepolia testnet that enables us to obtain the rate of this specific token pair. So we can then use the rate that is obtained from this smart contract to perform our calculation. So now we understand what the price feed contract is. Then let's now look at if we understand what the price feed contract is. Now let's look at how to interact with with the Chainlink smart contract. So now, but before we proceed, as usual, anytime we are performing intercontract interaction, two things are important. We need the contract address and we need the interface. The contract address just basically tells us where a specific smart contract. It gives us a reference to a specific smart contract. Then the next thing that is needed is we need the interface. So interface basically anytime we are performing contract interaction, we need to look for a way of telling solidity of how the contract you want to interact with look like. So, and for us to inform solidity of how the contract we want to interact with look like, that is why we are making use of that is why we are making use of and what we are making use of an interface. Now let's bring our interface into our smart contract. So now, if we scroll down, let's go ahead to get our interface for Chainlink. So now, copy this, then paste it at the top section. So now, actually, there are about two different ways of obtaining the interface for the aggregator V3 contract, but the the way we are importing the interfaces, we are actually importing the interface directly from Remis. The reason why we are able to do it like that is because there's a package called Chainlink contract package. So in this package, it contains useful contracts, and it also contains the interfaces of the various contracts. So now Remix itself have pre-installed this package. So whenever Remix sees this import keyword, see this line of code, then it automatically bring in this interface that we need in this our code. It automatically makes it available for us. Then if you see the left hand section where we do create our files, you click on the text folder, then scroll down, then click on the npm folder, then chainlink, then contract, then source, then version 8 interface. Now, so this is the interface. So this is the code. So now this is the interface now. This is the interface we are currently importing into our into our USD converter .swl file. So this is the interface we are importing. So now, then after, since we have successfully been able to install ours, okay, now let's close the folder and let's go back to writing our code. Now we've been able to create our folder. We've been able to import our interface. The next task on the table is to create a function that enables us to interact with the contract we want to interact with. So now let's name the function with our function, and let's name get conversion rate. Let's name get conversion rate. Then our function. So now our function, what should be the visibility? Is it public? Is it external? Is it internal? But for this our contract, for in our case now, we want the contract to be accessible both inside and outside the contract. So now we just use the public, set the visibility to public. Then for this contract now, is it just, are we performing a transaction with the contract? Then since what this function is doing is basically reading from the blockchain, then it is best for us to set it as review. So which actually tells us that what we are only doing in this function is to read from the blockchain, and it is actually important for us to specify this because it also helps in gas optimization to avoid wastage and other. But in the later section, we are still going to talk about what data gas optimization is. So now, what are we going to be returning? We are going to be returning an unsigned integer. So with the help of the keyword when it comes to solidity, that we are returning an unsigned integer, which is going to be a unit. Then going to be a unit. Then next is now we need to start interacting with our smart contract. So now we've been able to import our interface of the contract you want to interact with. So then we go back to Chainlink, then click on the price feed address. So basically, there are various contracts that have been deployed to various networks. But for this our case now, we're making use of the Sepolia testnet. So now, then you scroll down, then let's copy the address of the contract we want to interact with on the Sepolia testnet. Then after scrolling down, then you import it, you paste it, let's paste it. So now next is for us to create a variable that will be referencing the contract we want to interact with. So now to now create that variable, we go back to Chainlink, then we click on the using data price feed. Then all you just want to copy is this aggregator interface. So we copy it. So now it is this aggregator interface that we have import here using this line of code, this import as so now we have import this aggregator interface using this line of code. So we want to create a variable of this type aggregator interface. So now the name of our variable will then be price field. Let's comment this address out. Will be price field contract, price field contract. Then let me copy the equal to symbol. My keyboard just right. It's well, why my keyboard is just not cooperating with me today. Now we've been able to now the next thing we do is copy the address, then paste it. So now with this now we've been able to create a variable. Let's add our semicolon so to prevent solidity from making noise. So now we've been able to create a variable that is referencing this aggregator v3 contract. So now the the next thing now is we can now start interacting with the contract. So then let's so, and as I said previously, the function on that contract that we basically want to interact with is this latest round contract. So now, since Solidity have helped us in to install the aggregator V3 interface, and I said that interface it just tell Solidity the type of contract is interacting. It's telling Solidity what is the structure of the contract is interacting, what type of function is there, how many variable is the function accepting. So this is basically the work of an interface. So it is just I'll just say it is just a norm. It is the norms of the normal practice in Solidity. So now since we've been able to do that, since Remix have helped us to install this training interface, then we can go down and see and see how the function we want to look like. How we can then we can then go and check how the function we want to interact with look like. We can check stuff like what type of variable is it accepting, is it and what is the visibility, is it an external function, what are the variables that are returned. So these are the information that the interface enables us to have access to. Then let's go and check. So and I said the function we basically want to interact with is this latest count data. Then you click on chain link, click on contract source, then depths, then interface. So then click on it. So now this is the interface. As I said, this is the contract we want to interact with, and you will see the function we want to interact with. It is so now we've seen that the function we are interacting with is an function that is having a visibility of external, it is a view function. Then what are the variables that are being returned, the round ID, the answer, and all that. But actually out of all this data that are being returned, what we are interested in is this answer variable. Then let's go back to our code and let's call the function. Now this is the price fit contract. Now this variable is now a reference to the contract. Then we can now access the latest round data. Now if you see when we input the when we try to access the various elements of this contract, there is a kind of like autocomplete that comes up. It is also because of this contract that this is how Remix is able to know the type of function we can interact with in the contract. So now the function we want to now call now is the latest round data. Now since we are not interested in all the data that is being returned, the data that we are actually interested in is just only the price. Then all we just need to do is to just to take all we need to do is to take only the data we're interested in, then input your equal to symbol, then to now to for us to take only the data we are interested in, then if you are not interested in the first data, just input a colon. Since we are interested in the second data, and the data is of the type what? The data is of the type int. So now we input our int keyword, then which is price. So then we are not interested in the third data, we are not interested in the fourth data, or we are not interested in the fifth data. So now this is actually similar to the structuring in JavaScript. So now we've been able to obtain the price. We've been able to obtain the price. Now let's click on save. Then we can now click on return price. So return price, then let's click on save, add a semicolon, I will put it. Okay. Now the reason why we are actually getting an error here is that okay, I know Solidity is kind of like similar to TypeScript. Solidity is statistically typed, and when we say language is statistically typed, that is we actually specify the type of values we actually inform Solidity beforehand the type of value that can be assigned to a variable and the type of the data type we are returning in the function, or the data we inform Solidity of the data type we are assigning to a variable and the data type we are returning. So that is basically what is that is basically what solidity that is what we mean when we say a language is statistically typed. Now we've also informed Solidity that we are returning an constant integer, but currently here it is an int. So now we need to convert this int to an int. So now to convert this into an int, we'll be making use of the int keyword. Then with this we have been let's remove thing. Now you see my contracts have run fine. My contract compiles without throwing an error. So now let's compile the contract and let's deploy it to the Sepolia testnet. No, before that I would like to implement my withdraw functionality, because no, testnet tokens, they are not unlimited, they are limited. So it is actually best for me to look for a way to get back the test token so that I can reuse it again. So now let me implement a function called withdraw, then public variable. Let's implement the withdraw functionality quickly. Actually, it's not part of what we have to do today, but it is actually important for me. So when it is sent to this contract, I'll be able to withdraw it back to my wallet. So withdraw, it's public, um, payable, well, then value, and address is dot balance. Sorry, payable, sorry, dot sender. Um, we've been able to implement the get conversion rate functionality, and this we've been able to implement the function that enables us to get the rate of a specific pair. Now it is time for us to deploy it to the Sepolia testnet, and so we can test it out. So now, so then click on the deploy button, um, approve transaction, then currently waiting for the transaction to go through. Okay, transaction still pending. Why? Okay, now transaction successful. Now let's click on the get conversion rate to check the rate of our of ETH USD. Now this is the value. If you see, actually to get the correct value, whatever is returned is actually in 8 decimal places. So to get the correct value, we need to count 8 to the left so that we will be able to get the correct value. So in our case now, if we have to count 8 to the left, our correct value will be 1, 2, 3, 4, 5, 6, 7, 8. So it will be 1,846.97. So this is actually the rate of ETH USD as at this time. So now the next function I want to implement is a function that actually enable us to convert USD to ether. Now this get conversion rate, now it basically enables us to get the rate. That is, it tells us how many units of it tells us how many dollars is equal to one ether. Now we got that information. Now let's now implement our function get, let's say convert ether. then the feasibility is public, then it's a payable function, then we know it so then okay. So now it's now time for us to implement the get the convert USD function should be convert here USD to Ether because that is what we basically want to do. Now the next step for us now, okay. Now before we proceed, you see this get conversion rate here now is what is actually returning is it is actually returning USD. That is, it is returning USD which is in 8 decimal places. Now in Solidity, the type of currency that Solidity or the type of currency that Ethereum understand are the Ether, the GWay, the WEI and the FINI. Those are the basically denomination of currencies that the Ethereum blockchain understand. So now we now need to look for a way of converting this our USD to Ether to the currency that the blockchain understand so that there will be effective communication so that the blockchain will understand what to do. There will be an effective communication. Now the way in which we can convert this value to value that Ethereum understand is that we'll be converting it to WEI, we'll be converting our USD to WEI. Now, for us to convert it to WEI, we need to convert this value here to 18 decimal places. So now, since the value that Chainlink is returning is actually already in 8 decimal places, so for us to now, the value that Chainlink is returning is in 8 decimal places. So to convert this to 18 decimal places, all we just have to do is to what? Multiply by 10 raised to power 10. So which will enable us to convert this value to what? To 18 decimal places, and we've been able to successfully convert the value to a value that the Ethereum blockchain understand, which is WEI. Then the next step is obtain our multiplication symbol. As I said, my keyboard is kind of like I'm not been able to do the right configurations, but let me try and get the exact symbol for Google. Easy anytime, kind of taking time. I check and so now we multiply it by 1 exponential n, so which is the same thing as 10 star expand 10. So it is the same thing with 1 exponential 10. Okay, let me add my semicolon back. Now, so now we've been able to convert our USD to WEI by converting it to 18 decimal places. So now the next step is to actually convert our um okay, okay. So sorry, what basically what you do here is we want to convert Ether to USD. The Ether that is being sent, we want to convert it to USD. Now, to now convert the Ether that is being sent to USD, then say you rate let's see, Ether value in USD. So you put the symbol and copy paste. Then the value that is being sent, our message of value times copy the notification symbol, then apply our rate, then Don't forget when you are performing multiplication, when you want to perform a arithmetic operation and there's multiplication and there's division, or there's multiplication, there's division, or there's addition and there's division. The first thing, always ensure that you actually carry out your multiplication or addition before you carry out your division. It is actually important. Now divided by 1 exponential 18. So let's add our semicolon, actually a function on exponential 18. So now next thing is for us to let's create another variable unit. Let's name it latest rate then public, so that we'll be able to access it externally. So let's add a semicolon and go down, let's go down. And so now with this now we've been able to convert the ether that is being sent to a corresponding value in USD. So the last step here is to update this latest rate variable and to obtain it. The latest whatever latest value that will be sent, this latest rate variable will be updated with the value that you get from this the latest rate variable will be updated with the ether value in USD variable. So now let's update it. Let's assign value to it. Paste and copy, paste, and let me save. Now we've been able to successfully implement our contract that enables us to convert ether to USD using Chainlink, which is an oracle that enables us to get off-chain data that enables us to bring off-chain data to the blockchain. Now it is now time for us to test the functionality of to test what we've worked on. Now let's deploy. Let me delete this contract again and let me deploy. So let me deploy. So now let's go to let me deploy first. Okay, while pending, let's go to the data unit converter. Go to the data unit converter. Then after going to the data unit converter, so we will be testing with 0 point. How many way should we test with? Okay, let's test with this way. Then let's paste it. Let's paste it here. Then let's click on this convert to convert ether to USD. Then let's click on confirm. So let's wait for the transaction to go through successfully. Okay, now let's check our rates. It's our latest rate. So now this is the value. Then notice that the value will actually be returned in way. So now, so the value will be returned in way. So to get the actual value, we need to divide this value by 18. So now so now we need to divide this value by 18. Then let's copy it. So to get the actual value, let's copy this value here. Copy and let's paste here. So now let's count 18 to the left one. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now our value will be 0.0.1864. So this is so now the value of the ether cent is the equivalent value of the ether cent is now equal to 0.1864. Now let's verify if what our smart contract value, let's verify if our smart contract is right or wrong. Now this is the value of the weight that we send in our smart contract, and this is the corresponding value in ether. Then let's go to some online platform that enables us to carry out various ether conversion, convert ether to USD, check check Coinbase, no not Coinbase, let's check this. So let me copy, then let me try this out. So now that we are correct. So now we got in our case we got 0.1864. It is actually still, it is correct, 0.1864, and here we have the 0.18. So now our smart contract is correct. The what we implemented is actually right. So now whenever you are building any smart contracts that require you to that says that whenever you are building any smart contract that ensure that a minimum amount of currency, like let's say minimum amount of USD must be sent before the user can will be able to contribute, or before the user will be able to interact with the smart contract. And there is need for you to convert the ether being sent to the corresponding value in USD. So this is the approach we have to take whenever you want to carry out uh, that kind of operation, or whenever you want to build that kind of smart contract. Thank you for coming. Have a wonderful day.